Example 7.
We're going to find the equation of a sinusoid. Remember, that's a sine curve. With the period of pi over 5, an amplitude of 6, and it goes to the point 2, 0.
Okay, so let's think about what we know. We know the amplitude is 6. That's our A.
That is...
Okay. And then we know it's a period of pi over 5. To find the period, we normally do 2 pi over B. We're saying that is pi over 5.
You have to know, just go with, what is your period? 2 pi over B.
Yep.
What does it equal pi over 5?
Okay, and then let's solve this. Do a little cross multiplication action. 2 pi times 5 is 10 pi.
By the way, we can do cross multiplication because there's an equal sign in the way, not because that's the rule of multiplying fractions.
Right. We're trying to solve for something. We've got a fraction on both sides. So to get B by itself, let's divide pi on both sides.
Divide by pi!
I could use some division by pi myself. I don't know what that means. B is 10. Okay, so that's another part.
We got A and B. Bingo, bango.
The other thing, and we really haven't talked about the whole vertical shift thing. I feel like...
Well, here's how vertical shift is going to go. Remember way back when we looked at stuff that was like all the different functions that moved around a little bit?
I remember.
Up and down, perhaps. Remember, all the up and down stuff took place outside the parentheses. So if we're going to move up and down, it's going to be right there, right there at the plus D or minus D part, as it were. Remember, if you're outside the parentheses, you do exactly what the equation says to do. If you're inside the parentheses, we're part of the super secret opposite society. And that doesn't change. That does not change for trig functions.
Right. It's all the same. So if we've got like a plus 3 out here, that means our graph is shifted up 3. And so then what it does for sine and cosine curves is it makes that be the place where we're oscillating around.
Right.
So that instead of like normal x-axis, we're oscillating like...
We're going to actually
If we're shifting up 3, then we're going to go up here to 3, and that's where we're going to start oscillating.
I like the way you think.
Okay. So the reason we're bringing that up, we've got the A, we've got the B. I don't think we're going to have a C here. I don't think we have a phase shift.
I feel like what you're saying is correct.
But this 0.20, I think, might be telling us about a vertical shift. So I feel like I need to draw out what's going on and think about this, because we've got an amplitude of 6, the 0.2 comma 0. Oh, maybe I'm wrong. Maybe this is a phase shift.
Oh, no.
Because 2, 0 is right here. So it could be that we've got this action going on. Like that's where our sine curve starts.
You know, maybe.
And that right there is a phase shift. It's not a shift up and down. It's a phase shift that we are moving to the right to.
No problem, though. It's not a problem.
We can do that.
We can still do that. We can totally do that. In fact, it's even easier now to do that. You know, it doesn't matter. It doesn't matter. They're both easy. They're both easy.
All right, so A is 6. B is 10.
Right.
But I feel like there's some issue that happens. Is there some issue that happens when we've got a phase shift and a number in front? Are we gonna subtract 2 here?
I believe so.
Okay, and then there's not a vertical shift.
Then there's not a vertical shift.
Okay, but okay. Here's what happens: is we put this in parentheses.
Yeah.
Okay.
There you go. Because we want to actually. To the x, we want to move 2.
Right.
But also to the x, we're going to multiply by 10. So we've got to look at those individually.
Yeah. So y equals 6 sine. And then if we distribute, that's 10x minus 20.
Yeah.
And so when we have a phase shift and we have a horizontal stretch or shrink, which is what's going on here, there is a little bit of an issue there that's kind of hard to wrap our heads around. I feel like.
Right.
So when you write this, stick it in parentheses and then distribute.
Practice it and graph it. Graph what you, hey, it's okay. Graph what you get and just double check. Does it go through the point that you're given? And you can look at a table of points to figure that out. Or you can go to your calculator and say x equals 2. What is y?
Yes.
It needs to be 0.
Yeah, it does.
And if it isn't, then you've got a whoops.
Yeah.
And just do a real quick check in here. 10 times 2
is 20.
Minus 20 is 0. The sign of 0 is 0. So we're good. There's
Awesome.
all kinds of ways
to
check.
We checked it.
Yeah.
It works. All right.
You know why it worked?
Because we did math. Because the stud monkey and super monkey here, are you thinking code word?
It's possible that might.
Code word monkey?
Yeah.
code word monkey?
Code word stud monkey.
Stud monkey?
Yeah.
Okay, code word stud monkey.
There you go.
So, and we said it out loud. So all you people who keep claiming that you're writing stuff down and don't see the code word, we just said it.
Claiming.
Find the equation on example 8 of a sinusoid that goes from a minimum value of y equals 5 at x equals 0 to a maximum value of y equals 25 at x equals 32.
I don't understand.
Should I draw a picture? Like, do you literally not understand, or are you being theatric? Y equals 5, x equals 0, so...
I'm never theatrical. Whatever.
Theatricosity. We've got this point 0, 5 that we know about, and we've got this point over here at x equals 32, y equals 25. Well, my scale's a little off here.
Like, wow, just a skosh. But that's okay. Go ahead and draw it. I mean, we know what's going on. So we're going to start low, finish high, and that's going to be like that part right there.
And it tells us that this is a minimum and that this is a maximum.
So here's the deal. Halfway between those 2 points is how far we've moved up our sine curve.
Right here, halfway?
Halfway.
So
Halfway
at
between.
16?
Yes.
And then halfway between a height of 5 and a height of 25.
Yes.
Those are 20 apart.
So 10.
So this is 10 right here.
So when we
our
go up
amplitude.
10 from 5. So 15. We're moving our whole equation up 15 units.
Yes, we are. So we're moving it up 15. So that's a vertical shift. So our D is 15.
Yes.
We've got an amplitude, which is A, of 10. What else do we have?
We've got a
B
phase
and C.
shift that moves from 0
We move from 0
to
over to 16,
16.
because we're talking about sine, and we're going to write it as a positive sign. So we need
Right.
to know where is it in the middle. It's not
Right.
at 0 this time. Where is it in the middle and then going up? So we
Right.
went right 16. So that means that C is negative 16.
Right.
The period.
The period, well, we've got half of it right here.
And that took us 32 to get half.
And it took us 32 to get half. So
64 should be a whole.
So 64 should be a whole. So
So-
the period, which remember formula is
2 pi over b
has
equals,
to equal 64. It has to. We don't have a choice.
And so we can do a little cross multiplication kind of thing.
Only because there's an equal sign in there. Math mistake number 1 for pre-calc kids and
I
higher
think you've
kids.
used number 1.
Well, math mistake number 1B. You can't just cross multiply everywhere when you want to.
Yeah.
You can only cross
Only certain
multiply
times.
over an equal sign.
So we could simplify 2 over 64 and make this be pi over 32.
That sounds great.
And let's write out our sinusoid now. We've got y equals a sine b.
And we saw in the previous example we need to open up parentheses.
Open a parentheses.
Come on over, Mr. Kane. We're wrapping up this problem.
Yeah, we're recording right now, Mr. Kane, but you can say hi to all the chillins, or you can choose not to.
Not to is a good choice.
Okay.
They just heard that, so
Okay.
now you've offended them.
No, it's okay. Okay, so that's it.
That's it right there. Now,
Leave
if you
it.
want to send the pi over 32 through, you certainly may.
But you can leave it like
You
this.
can leave it like that because that's how we know what that means.
I know what that means.
I know what that
you know
means,
what that
too.
means. Everyone knows what that means.
Yeah.
So
All right, good talk. Good talk.